Hey, Jakob.
Hello, how are you?
Good, how are you?
I'm fine.
Hey, Boris.
Hello. How you doing, guys?
So Gali still is also away this week. So he asked me to open the call just in case there are issues or things we want to discuss as well. Let's wait a few more minutes to see if there is quorum basically today.
Sure. Even if not quorum, if you and Aga can help me walk through the Ansible playbook that I created for the internal lab,
That would be perfect. Yeah.
that would be very useful for me.
Definitely on the things. And I know that you have asked basically like some questions about Pixie. I have some meetings tomorrow scheduled to actually like clarify basically a few things on the side.
Perfect.
So I need to come. I haven't forgotten about you. I actually like schedule it like a few things on our side.
Excellent.
Hey, Daniel. As I was saying to Boris and Aga, Gali is not going to be available today. So he asked me to open the call basically and have any issues that we actually have to discuss today. Okay. Srinivas, also for you, I mean, any topics, anything that wants anybody to bring to the table for discussion for today?
No, from my side.
Not from your side, okay.
Yeah.
Daniel, anything that you want to bring up basically, right? I mean, on from your table, from your side?
One thing, I think it's been a while ago, I think Boris remember this discussion. We discussed the SM-bias tables, what should be included, what do we need to standardize, the what SM-bias tables should provide on XPUs. I think initially we had like analysis what currently was proposed and what we have, what kind of requirements we have on ARM system for a SM-bias table. So I don't know if we want to discuss that subject and see if we can move in do any progress in standardizing SM-bias records. That's one thing that I have on my mind.
Yeah, I remember the discussion for sure.
Yeah, it was like maybe 6 months ago or even more.
Yeah, for sure. I'll post 2 links in regard to the discussion. Nothing changed in that area, but for others on the call, except for me and Daniel, just to catch up. So we have the SM-bias validation tool, which can run on different DPUs and IPUs and validate different tables. So that's one option, for example. So if we are standardizing on the tool, in addition to the specification itself, we can actually create or update this tool to help us validate that standardization is in place for different vendors. And another repository I shared, this is the bridge, which basically exposes SM-bias information over gRPC. Please posted examples.
Good. So there has not been any progress, right? I mean besides these two posts that we have on the things over there. Do we need to do anything on this one, Boris?
Yeah, the idea here is that we need to standardize on the fields and sections, and then update the SM-bias validation tool and run it on different vendors and make sure that all the vendors are compliant.
Okay.
Yeah.
Yeah, I think we have to also decide what minimum what records should be included in the SMBIAS tables. I think that was one of the topics. So if you want to standardize that, we need to decide what should be included in SMBIAS and what should be optional.
Yep, I agree.
I'm trying to find. I think I created the XML spreadsheet with the which compare the what current tools checking for and what the ARM system ready is checking for. But it's been a while ago. I'm trying to search for it, and let me see if I can find it.
So we have that
Yeah.
SMBIAS from Daniel, and I want to walk through the Ansible playbook I created for our lab, which incorporates all the DPUs, IPUs, servers, and switches, and ask people for feedback.
Okay. The other thing I've been spending some time is on monitoring, basically, right? I mean, we have a tool, basically, right? I mean, that actually gives a bunch of like monitoring information from the DPU. That's actually coming mainly from the ARM side, from the OS. Is this something that we are going to be covering here as well?
Yes,
Okay.
it's part of the playbooks that I created already, and we have all the dashboards, or some of the dashboards ready and showing that information already today.
So you're getting like things like power consumption or things, information that you're getting from the DPU side?
Not everything, but some, yes. And the
Okay,
idea
that would
is
be good. Okay.
Yeah, the idea is once we have this up and running, we can then extend it to have more metrics added as we go. I can cover this part of it.
Good. And the issue that we have it here, I don't know, Boris, I mean, let's cover it as well. We have like pipelines that actually go to Grafana and Prometheus and all those kind of things, or like different kind of mechanisms.
I created all of this, including Prometheus.
Perfect. Then let's go through that one. That's exactly what I was spending time like in the last few weeks. Okay, good.
Excellent.
Okay, Boris, all yours then.
All right. So I'll start with covering the inventory and the Ansible playbook I created for our lab. That's a different than the collection for that we were working for the based on Redfish.
Okay.
Because the idea is different. The idea here is we now have the lab and we have a lot of infrastructure in the lab, and I wanted to create an automation to manage that lab. And because we have a lot of vendors and a lot of different equipment, so I wanted to have this automated. So let's walk through that. And then once we finish covering this, we'll spend the time on the monitoring solution that I created, and we can cover that as well, if that works. Excellent. Feel free to stop me and ask questions, by the way. Okay, so let's start with the inventory file. So this is our OPI lab. We have 4 servers from different vendors, Dell and HP and Supermicro, I think. So I defined, we call them DH1234. This is the IP addresses according to the IP markdown file that people can look. This group is for BMC of those servers. If it's Dell, it's iDRAC. If it's HP, it's ILO. And here, obviously, we're SSHing into the server, and here we're using local collection because we are going to use Redfish for the BMC. I created a group for all the DPUs. We have one for Pensando, one for NVIDIA, one for Marvell, and one for Intel. Intel, in order to access AGA, this is, again, for your attention as well. Intel, because we have to use the IMC as a jump host, this is what exactly I configured. So basically, I'm using IMC as a jump host in order to SSH into the ACC. I defined, like in servers, I defined all the BMCs in a separate group. We have group for the traffic generator, I think based on Supermicro server. So our CPU and the BMC, we have one management server that recently arrived. This is when we run all the infrastructure like Prometheus, Grafana, DHCP server, Bootstrap, Ansible, master management. And we have two switches, both from Arista, one top of the rack switch and one for 100 gig connectivity. And this reflects the picture of our lab that we have. We have top of the rack switch, we have KVMs, we have F5 VPN to access the lab. We have 1, 2, 3, 4 servers. In each server, we have GPU. We have one for AMD Pensando, one for NVIDIA, one for Marvell, one for Intel, Dayton Peak, Mount Evans. And we have everything connected to 100 gig switch as high band communication. And we have traffic generator to generate traffic over 100 gig connectivity. And obviously, top of the rack switch for management. So this reflects one-to-one the inventory that we have currently. Any questions before I jump into the actual playbook?
Go ahead. I have a few things I was going to ask you, but keep on going on the side. So
Okay.
you don't have Bluefield 3s. That's what I was going to ask you, right? I mean,
We just about to order one.
Okay,
Yes, we
okay,
didn't have it yet.
okay.
Mhm.
Okay.
Correct. Okay. So now the currently everything in a single file just for simplicity, but we can definitely split it into different YAML files according to the topics. And just go through quickly. The idea here, the main concept is we have all this equipment. I want to keep it up to date with all the packages, all the firmware versions. Every time Intel, NVIDIA releases a new Docker, Intel releases a new SDK, I want to automatically be able to apply all of this. Every time we make change in the switch configuration file, for example, or Telegraph Prometheus Grafana configuration, I want to be applied automatically as well. So let's go through this quickly. So this is just synchronizing all the clocks. This is for switches. It's using the Arista collection to run the show version. And in my to-do list to uncomment this and enable actual configuration sending to the Arista switch from the local folders. This is all the servers. Server 1, 2, 3, 4. Basically, using the Redfish community general, I'm just fetching all the firmware inventory for documentation purposes. And I'm fetching all the BIOS attributes. The idea here is to finish the to-do list, basically to configure all the BIOS using Redfish, for example, SRV enabled, or like power always on, like all the BIOS changes that we do manually on the servers. I want to automate this. This section is for Mount Evans. On Intel Mount Evans, I enable proxy and port forwarding, basically using the Squid and Socket. I created a service file for the socket. This is for OpenTelemetry to pour forward the Telegraph metrics over gRPC. And I enable Squid in order to create the forward proxy for HTTP and HTTPS. In this section, I install Docker. Again, for Mount Evans, I need to use the proxy that was previously installed here. So I have the proxy for Mount Evans. All the rest don't need any proxy. I install Python, SSH Git, and I remove the old Docker and install the new Docker packages and start the Docker daemon.
Okay, so you install Docker in the DPU, right? I mean, that's not
In the DPU,
okay.
yes.
So you haven't done anything right now on the x86 host. You're actually managing
I
everything.
am. You see here, this playbook is running on all the servers, all the hosts, on all the traffic generators, all the DPUs, and on the management server. So I do have all the Dockers running everywhere.
But have you provisioned the OS on the
Yes.
on the x86 side before?
Yes,
So
yes.
you have a playbook to install.
I
Basically.
don't have a playbook. Currently, it's in To-Do. We did
Right.
it manually using Pixie and did Ubuntu for everything. You can see it in these manual steps, server setup. So for manual instructions, we provisioned Ubuntu 22.04 manually on those servers.
Okay.
And my idea is to add in the playbook Pixie booting or virtual media mount, whatever, the Ubuntu on the x86 servers.
And you didn't use the DPU to install that one. You actually use a 1 gig network from the hardware basically to do the Pixie installation. Okay.
Currently, the Pixie is not in this playbook. Currently, I assumed that we did manual installation of all the servers, and it's not part of playbook. It's on the to-do list to edit it into the servers. But once the Ubuntu is installed, I do install Docker automatically everywhere, including x86, GPUs, management, and traffic generators.
Okay.
This is all. By the way, this playbook is working and running right now. Let's go into monitoring. So for monitoring, what I did is a monitoring. So I run everything as containers. I run the monitoring agent on x86, traffic generators, and DPUs. Each of them running one single container for a Telegraph. Okay. So in order to make it run, I copy the entire Telegraph folder. I have created the Telegraph D folder with all the configuration. We'll walk through this in a second. So I copy the entire Telegraph config file into the destination. For NVIDIA, I need to run the emulation service. This is for temperature measurement. I need to run the SPDK target or Mellanox Snap. This is for SPDK statistics. It's all working. And once I did all these services, now I can run the Telegraph container using 128 version for now, mounting basically two folders. One is for Telegraph and one is for emulation parameters for temperature. And we'll go through the monitoring in a little bit more details in a minute once I finish this playbook. For Intel, I did a very similar thing. For Intel Mount Evans, I had to use proxy because ACC access is through IMC. So due to existing bug, I needed to downgrade the requests package. And then once I did that, I can now run the Telegraph container, the same Telegraph 128, with mounting the Mount Evans configuration, as you see here. Very similar to what NVIDIA does. For everything else, I'm running not Mount Evans on Bluefield, I'm running a standard Telegraph container on everything else. So means on x86 servers and on other DPUs and traffic generators. If you look at the picture of how it looks like, so I created a OpenTelemetry Markdown file. This is how it looks like. So on every server, I have the Telegraph agent running. On every DPU, I have Telegraph agent running. And I deployed the OpenTelemetry gateway collector to aggregate all of this. And I stream everything to Prometheus and then visualize everything with Grafana. If we look at the Prometheus, so Prometheus is running. Here I execute just a simple command, memory free, that shows all the different instances of Telegraph that are sending metrics right now. So we see one for Bluefield, one for server 1, server 2, server 3, server 4, Intel IPU ACC, a management server, and traffic generator. If we go into the Grafana dashboard, you can see the dashboard for temperature that I created. a dashboard for disk utilization, a dashboard for memory utilization, and a dashboard for the CPUs. I also have additional dashboard that I created for Arista switches. It's not populated right now, it's work in progress, but FYI, we can add as many dashboards as we want. For example, Jose, you were talking about, let's add more dashboards. Absolutely. This is just what I had time myself to add, but if people want to contribute to this, absolutely no questions. For sure. Okay, let's continue with after the monitoring. So for the management server, I decided not to implement anything with Ansible because I run everything using the Docker Compose. So the only playbook for management server is just to run the Docker Compose on the management server. The Docker Compose here you can see has telegraph of itself because I want to monitor the management server itself. I have the gateway aggregator collector. I have the Prometheus running. I have the Grafana running with all the dashboards and configurations. I have MySQL running for the semaphore. Semaphore is a Ansible UI. I have the semaphore itself running. So you can see here, I have the dashboard of Ansible UI. We can see everything here, and we can run the Ansible automation that I showed you from the UI. We have the Portainer. Portainer is a Docker visualization. So we can log in here to the management server, and we can see in visual way all the containers that are running, all the images that we download, all the networks we created, all the volumes that we are using. Basically, it's a Docker a pretty good visualizer for Docker and containers. So that's it for now. Next, I will add here the DHCP server, SZTP server, Bootstrap, and all of that. Everything that we need to run on the management server will be in the Docker Compose file. This is just to simplify the Ansible for the management. So once I did with management, now I have a very important playbook to upgrade Intel Mount Evans firmware on both ACC and IMC. So this is the ARM cores and the IMC, the BMC. So I fetch the running versions here. For now, I'm using 1.4 release. I defined all the PLDM images and ACC evaluation images, and basically I'm running this entire playbook, checking if file exists remotely. If not, I copy and extract it. But eventually what I did is I run the IPU update utility for Intel Mount Evans cards. I do the same for ACC. This is the main ARM cores of Intel. And for there, we have the ACC OS partition script that we can run to update the partitions.
Okay, so you're using the IMC tools, right? In
Yes.
order to achieve that. Okay, good.
Absolutely. So Aga, I will really appreciate if you would just look through this offline, and if you have any comments, if you want to test it, or any feedback here, any help is very appreciated.
Yes, yes, I will.
Absolutely. So because this was so easy for Intel, I did the same for NVIDIA Bluefield. So for NVIDIA Bluefield, specifically for here, I wanted just to push the BFB really quickly, Jose, so I didn't use the Ansible playbooks that we created, but instead here I just download from Mellanox, I download the latest 2.7 production BFB file here. This is where I downloaded, and then I just put it to dev archim boot using the x86 server for now.
Correct. I mean, you're installing from the x86 side. You are not like doing the installation from the network side, basically. The old way to do it on the side.
Correct.
Okay.
And again, this is not necessarily this is how it's supposed to stay for the future, but I think I just wanted to get it quickly done for other purposes, and then we can iterate and exchange as we want. So here I just do the LSPCI and the cat of MISC of Archim, download the file, and then they just dump it into the Archim interface, and that's it.
Good.
So this is just quick and dirty. We can use also BFB installer utility here in my to-do list instead of cat. So very simple thing. I started to work also on Pensando, MD Pensando DSC installation. Again, also from the x86, I just use these commands just for debug information. It's not actually upgrading anything. And Rahul and Anil helping me on the Marvell CN106 to finish this section of updating the Marvell card as well. It's obviously work in progress, as you can see here.
So this would be the area that you would like to converge, right? I mean, that you have a common set of like recipes across the different vendors.
Exactly.
Because
this is a real example
Yeah.
of a real hardware lab that we have with different server vendors, DPU vendors, and you can see how much difference we have in all these different areas. So potentially this is a good explanation, example, visualization of the problem that we're facing. Everybody is doing very different. So ideally, I would like to do it in the same way eventually for everybody. So absolutely, that's my take on this.
And then on the next step, right? I mean, because you are not doing any configuration here, right? I mean, you are not doing any password or any kind of accounts or any kind of like things on the side. So you like to configure
everything.
Basically, right? I mean, so have a configure.yaml again.
Yes.
If you do it today, it would be different for every vendor, right? I mean, and you would like to actually get, right? I mean, the config.yaml that would allow you to handle it like in a more unified way. Okay.
Absolutely, 100%. And once we have this done, what my goals for the next are is, first of all, to manage the lab as GitOps environment, because this is what our customer needs. For example, I go to Telegraph D and I have my Bluefield 2 configuration file, and I want to change the password, or I want to change the port, or I want to change the name of the Bluefield temperature file. For example, here, I change it, I create a pull request. When the pull request is merged, I want to automatically trigger the Ansible using GitHub Actions or the Ansible cron periodic job, whatever we want, in order for this configuration to take effect after the pull request is merged. Same for Intel Mount Evans, for example. Currently, Mount Evans is not streaming any temperature because temperature is coming from the ICC. Once I fix this section and we have the temperature, I want the pull request merged. This file is automatically using the Ansible playbook you saw previously propagated to all these servers and IPUs and everything, and then we stream more metrics. For example, recently I added the disk configuration. Once I add it again, I want it to populate automatically everywhere. So there are a couple of things I want to achieve here. As you can see, one is to be GitOps oriented. One is to visualize there is a problem of installation, upgrade, lifecycle, but also configuration for there, like you rightfully mentioned. And the last thing I want is basically goal of this project is to showcase demos. So for example, we created a IPsec demo with Intel and Marvell and NVIDIA with different scripts that we are using. So once this infrastructure is provisioned, I want to either through Playbook or, probably through Playbook as well, to run the demo. Like choose what demo I want to run it. So all the demo configuration is as well very easy on top of the basic infrastructure management. It's kind of next or final step. Once the infrastructure is ready, let's tackle the demo automation. Here, for example, we created a draft pull request for automating EVPN configuration. So, for example, you see all of those are manual steps. So we want to converge on all of these steps and maybe also using the Ansible automation, just an example. But first, we need to figure out that everything is automatic. For Intel, they're going to already released the next version. Same for NVIDIA. Docker is released all the time. So I want to, just change this variable from 2.7 to something else, and just apply the playbook, and it will be automatically upgraded and reconfigured. Yeah, questions? Sure.
Yeah, so thanks, Boris, for the walkthrough. Regarding the IPsec, which you were mentioning, more of a clarification comment. So are you using the standard OPI API APIs there, or is it like proprietary vendor-specific APIs for configuring and setting up the IPsec tunnels?
Well, we're supposed to use the standard OPI APIs, running the strong one as a container on both sides, and then using the proprietary, obviously, offload engines integrated with the strong one to create the IPsec tunnels. But I didn't check the demos folder for quite some time, so I don't remember what's done. We also have the PyDPU project with here different IPsec sections. I think it's not implemented. So I don't know what the latest of this. I didn't check on this for quite some time, but it's supposed to using the standard API. That's our entire idea of doing the demos.
Okay, yep. Good, thanks.
Yeah, you can see here, for example, in Traffic Generator, Mercha created the deployment with IPsec YAML, and using Docker Compose and the different Traffic Generator YAML and the configuration files and all of that. So swarmctl. So I didn't look at this for quite some time. So.
No, that's fine. Okay, thanks.
Any questions on monitoring or playbooks?
Yeah.
Okay, for you, this
All
is
of
what I
that.
catch you. Yeah, sorry, go ahead, please. Aga, is it?
Aga, please go
Yeah, I
ahead.
just wanted to ask whether that's under the link you've provided, because I see here this is the OPI POC project. Okay.
Yeah.
All right.
So Boris, my only question would be, right? I mean, so at least from the NVIDIA side, is we do have a container with all the monitoring that runs both on the DPU side and on the host side. I mean, it's the Docker telemetry services that actually talks to Grafana and talks to Prometheus and Fluent as well, and a few things. I would like to see, right? I mean, what are the differences on that configuration compared, because it seems you created a new container, right? I mean, that you're actually collecting information from. And I'd like to understand what is the difference, basically, I mean, discuss with our monitoring team, basically, how this is actually like handling. I'll send a note after this call to them to see how we are doing it. And because, I mean, we're doing both for the switches side and for the network side as well.
Exactly.
So that's the telemetry services. I mean, if you look at this public, in the Docker telemetry services would be the.
I met with your monitoring team on this. Yes, absolutely.
So who you met with Eli, with Michal? Okay.
Yeah, all of those guys. Yeah.
Perfect. Okay, excellent. So
here I just wanted to create an example based on Telegraph, not your proprietary service, so you can see what we monitor here. We monitor the Redfish. Use for power. We monitor the SPDK using the JSON RPC with BDEV-GET IOStats. Obviously, CPU memory, netstat, Bluefield temperature in a proprietary way, and that's it for now. So we can take it into two ways. One way is not to use Telegraph on Bluefield, but use NVIDIA telemetry collector. But it will still stream to the OpenTelemetry gateway aggregator that I showed everything, and we'll see it in Prometheus, and we'll see it in Grafana dashboards. Then we can also use help from your team to give us a little bit more dashboards here, so we can make it nicer, because all of this is currently what I created half an hour that I had between my calls.
Mhm.
Another way is to keep the NVIDIA here to use Telegraph container and just add more stuff to be on par with what your collector is gathering. So either way, I'm fine with both methods.
Let me discuss, right? I mean, internally with our side. I mean, the important is you have some generic counters, right? I mean, on the side, but really like knowing the counters that really matters, right? I mean, is really like
Yep.
I mean, which ones are the ones that we should be focusing on, right? I mean,
One of the important things is that everybody, all the vendors are streaming to OpenTelemetry in OpenTelemetry format to the OpenTelemetry aggregator, and then not directly to Prometheus and Grafana, because that is what we standardize on OpenTelemetry. So this is what we're doing here. And then the OpenTelemetry gateway collector is streaming everything to Prometheus, and then we're using the Prometheus database to visualize Grafana. So that's fine. That's number one. And number two, you can see here as well, there is a lot of opportunity that I wanted also to create these examples to show the differences between the vendors. For example, you can see Bluefield, this is how the temperature we collect.
Mhm.
In servers, this is how we collect the temperature.
Mhm.
And in Mount Evans, this is how we collect the temperature. So for me, the metrics standardization is also a good topic that we can then discuss and use this project that already deployed and streaming, and we can play with it, the dashboards and everything to also show the differences and try to mitigate and standardize in this specific area as well.
And today, our container actually goes directly to Prometheus. It doesn't go to OpenTelemetry as far as I have used it, right? I mean, the documentation is actually I mentioned directly
know.
to go to Prometheus. Yeah,
I know.
I have to raise this question to the team.
Yeah, we have to go through OpenTelemetry because in OPI we standardize on OpenTelemetry.
Okay, perfect.
For AGA for Intel, I suggest also in this area, please take a look at what I did here. Basically on ICC, as I said, I'm running Telegraph. This is a very basic configuration. Obviously, there is a lot of room for improvement. I think there are more than 1,000 different plugins or hundreds of different input plugins that exist in Telegraph. So we can see and now start to add more and more stuff in addition to the regular netstat to collect more metrics. But I think it's a good example how on Intel cards we can collect metrics as well. I'm not sure I saw in your private documentation that you shared with me, like Intel shared with me, anything regarding the monitoring solutions. So this could be a nice example, maybe, that we can publish together.
Okay.
And then obviously we can add here the ATH tools and everything. Like it's all up and running for the grabs.
Sure.
Fantastic, Boris. I mean, this is very, very nice, right? I mean, so we do have things internally on our side, but really this is a good way that we could actually have somewhere that we can actually share and discuss these things publicly. So this is really, really good.
Yeah. And I always hated that our calls are very theoretical.
Yeah.
And I always want to have in front of us some working example that we can all kind of look at, run it in our labs and see what's working, what's not working, and how we can take it forward. So thanks for your time.
No, good. Okay, I have to give you a bunch of internal discussions and get back to you on feedback on a few things that we discussed today.
And if people have questions, reach out to me directly or create an issue or post in Slack channel, whatever you want. If you want to work or help or change something or unpublish something that was published by mistake, any type of comments are really good.
Okay. That was really insightful. Practical usage.
Yeah. I think this is what we're doing currently in Dell internally as well in different areas, and this is what customers usually how they deploy things stuff. So I think that's a real life example. So.
Yep. Excellent.
Thank you.
Anything else that we discussed today? It was really good, Boris. I mean, thank you very much. Anything else that we discussed today? Anybody else? Okay, then let's resume. Yeah, go ahead.
Should we talk about SM bias today, or we will do it next time? I found the spreadsheet what was presented a while ago to this group, which outline the SM bias tables, what's supported by the tool what Boris mentioned, and what's supported by the what defined on system ready for ARM platforms. Do you want to go
Yeah,
review it?
I think it would be good, right? I mean, if you review it again, Daniel, I have not seen it, right? I mean, I have not joined, and try to find out who would be the right person in our at NVIDIA that would actually be able to come back to you and give you some answers. If you can share it, like just give a short overview, that would be great, because then I know who I want to ask and who I want to actually bother. Okay.
Okay, so you want to do it right now, right?
Yes, yeah, do that.
Right.
Now let's give us a short overview, remind us, right? I mean, what it was, right? I mean, and what is the issues? What are the issues? And then we could actually discuss in 2 weeks, right? I mean, next steps. Okay.
Okay, sounds good. Okay, so I shared a spreadsheet what was created to review the differences between the tool. As Boris mentioned, we have the tool which is using the we have tool FWTS, which is used by the our system ready validation, ARM system ready validation mechanism. And there is the tool called SM bias validation tool. I think, Boris, it's been published on GitHub, right, under OPI.
Yep.
As I remember. So there is a difference between them. SM bias validation tool, I think it's based on the Google implementation of the SM bias validation. It validates certain SM bias tables, and the FWTS tool, which is using DMI check, validates a different set of the SM bias tables. But there are some, we have tables which are common for both these tools, and some tables which are not. So I mark in green, which is validated by FWTS tool, which is used by ARM, and mark in yellow, which is validated by SM bias tool, but not by FWTS tool. So as an example here on the table on the SM bias type 0, we can see what the vendor bias version and bias release date are validated by both tools. But SM bias validation tool validates size, and FWTS does not do that. But FWTS validates the bias characteristic extension by 2, but the SM bias validation tool doesn't. And there are some fields marked missing. They're not validated by either of those tools. So I think the purpose of this table is to show what we have in SM bias validation and what we have in system ready, and decide what will be default tables, what should be validated for the DPU.
So questions and comments. I mean, the first one. I mean, can you share this link in the chat, or I mean, also write the links to the tools that as well on the chat.
Sure. I don't know, Boris, if you have linked to the SM bias validation tool. I think it's on GitHub.
That's the validation tool I posted to the chat. Yeah.
And then the second question will be: have you tried to run this one against the machines that Boris has in the lab and see what we are doing, how we are passing or failing?
Yes, we did. Yes.
So it's without embarrassing anybody. Shall we share those numbers, or how do you want to do it that side, Boris?
We want to find a place to publish it, right? This is where we stopped previously. So we can run both of those tools, no problem. We can see the exceptions that are raised or fields that are missing. And we just need to decide collectively in what format and where exactly we want to publish that and how, and just do it. So no, absolutely no objection, but somebody just need to find time and actually do it.
So the idea would be, I mean, what I would recommend is why don't you run it against like Bluefield and share it with NVIDIA, against Mount Evans and share it with Intel to give the different vendors a chance to respond, right? I mean, to see if there is missing on, on the side. I want to ask, I mean, to run those tools against our hardware, right? I mean, as well, right? I mean, on my side, right? I mean, to see where we stand with these kind of like options, and then come back to you as well, right? I mean, but I mean, if we can run it easily ourselves, right? I mean, in the hardware that you actually have, Boris, just to get a first sanity check would be great.
Okay, and a little bit more generic question. Why do you want to retrieve all this information from SMBIOS? Is this the only way we are planning to do that, or you would like it through other tools as well, and SMBIOS is just an example?
SMBIOS is the most standard way we retrieve those information for the applications that are running on the card inside, like in the server. When we usually port the application from x86 to DPUs and APUs, SMBIOS is the most standard way you actually fetch all of this, like serial number and stuff. Obviously, Redfish for out of band, this is going to be also valid and applicable.
That was my second question.
Absolutely,
because it looked like natural for the other tools as well.
Absolutely. So and they all should match, right? So
yes.
SMBIOS, in my point of view, SMBIOS is when application running inside the ARM cores wants to access to this information, and Redfish is more out of band management when some kind of tool wants to access it through Redfish, something like that.
Or control the inventory, right? Yeah, exactly.
And they all should match. Obviously, you shouldn't have different.
Definitely. And that's challenging.
I know.
Yeah. So I think we need. So the question is how we're going to define the standardization for SMBIOS. Should we use one tool or another, or merge the validation of both tools together? So that's what we need input from the vendors, what kind of fields they need, what they require to have an SMBIOS. From the ARM side, we have standardized it by using FWTS and using DMI check. This is what this column has. That's what we do on ARM side. So we need to identify if vendors would like to also include those fields, what marked by green, what we defined on the ARM side, or they are not required, they're optional, and also review the SMBIOS table, what it does, SMBIOS validation tool, what it does, and what missing or what is not needed. So yeah, we need input from the platform device vendors and see how we can proceed with this.
So from my side, from the NVIDIA side, I want to ask the questions. You gave me enough information, Daniil, to actually like go to the experts and actually like get them some feedback basically from their side basically. I can tell you right in 2 weeks I would let you know what is the answer from.
By the way, Jose Naga, I found the actual run that we did with those tools against Bluefield and others.
Okay.
I'll post it in the chat so you can all get this. Look at this offline.
Perfect. Good. Excellent.
And I also post the link to the spreadsheet, so you can check what each tool supports and see what what you think should be included into the validation and what should be optional. So in general idea, we need to think how we're going to handle this situation when we have differences. Do we need those fields or we don't need those? They should be optional. They should be defined as required. So
I'll get you to know. So I'm trying to find out, do you have MAC addresses, right? I mean trying to find out the MAC addresses. That's one that was causing me pain lately in that list. It's a row for MAC addresses. One thing that was causing me pain on our side lately.
you need MAC address for
the optical ports, the external ports. I'll take a look at that. Don't worry, Daniel. I'll take a look at that list for sure. Okay, excellent. Anything else?
Yeah, very quickly. I'm going through this legend. So you have this OPI and then system ready BBR. So what does that signify?
BBR, this is the ARM base boot requirements.
You have this corresponding column as well, right? The OPI initial and then system ready BBR.
Yeah, this is here. Yeah, this is the BBR defined as part of the ARM system ready program, which defines the requirements for SMBIOS. So I'm kind of here and compare what OPI initial, what the initial means, what OPI is using SMBIOS validation tool. So here we compare what the initial OPI is using and what is the SMBIOS base boot requirements is using on ARM side.
But isn't it OPI initial implementations? We were using SMBIOS, and ideally it should actually match with the SMBIOS column, isn't it?
You're talking about this?
Yeah.
Yeah, this is one. So the table that says the SMBIOS validation tool has the support for BIOS version, for example. And our FWTS tool, this is the actual implementation of the validation, also has the validation for this field. So in here, we're saying the OPI, which is using the SMBIOS validation tool, supports it. And the system ready, which is using FWTS, also support it. So we're saying what the both OPI initial system BIOS validation tool and the system ready BBR, which is using FWTS, both of them support. So we're good in this place. We agreed what this field should be supported.
Okay. But then in the next section, so if you scroll a little bit on the left-hand side, the section, I think it's the system information, right? After the BIOS information that you have as a next section. So if you scroll a little bit on, okay, I think it was on my end. Sorry. So you have this type 1 as system information, and there the SMBIOS validation tool doesn't support these, right? And it's only FWTS that supports it, but you have it in OPI initial that it's required and / supports, which is a little bit contradictory, isn't it?
Let me see. Yeah, I see your point. Yeah, I think what we did on this, I think that was the proposal. What we should. Okay, I'm sorry. It's been a while ago. I'm trying to.
That's okay. I think it means that it should be supported, right? It doesn't mean that it has or it is already being supported, right? So it's more of a requirement than like the compliancy.
Right. So these two columns, it's simple analysis of both tools, what they support. And here, this is show what required by system ready. And this is what the proposal for initial OPI requirements for SMBIOS.
So the last two columns are mainly just a requirements from system ready or the OPI point of view.
Right. That's what we have on ARM currently. And this is the proposal for OPI, what we should have for SMBIOS tables.
Okay. Yeah. Thank you.
Yeah, I'm sorry. I was trying to recall the legend on this.
That's
table.
okay.
Yeah, I'll share this spreadsheet later in a Slack channel for our work group, if it's fine.
Perfect. Okay. Very good. Any other things, any other topics, any other questions, comments? Great meeting today. So thank you very much for Boris and Daniel, right? I mean, I think it was very useful information today. Good. Talk to you.
Thank you.
Thank you.
Thank you.